This is Saxon Advanced Math, lesson 96A. This is more double angle identities. So we're going to jump right in with an example here. This is example 96.1. Show that the sine x plus cosine x squared equals 1 plus sine of 2x. Now remember, we're just showing. So this is just using the identities, using the things we know to substitute in to show that one thing is equal to another. So I'm going to always work on the left, and I put that in there, a little asterisk for us. So we're just going to use little quotation marks as we bring that right-hand side down all the way to the end. But we're going to, first of all, show that this is the same as this. So what would I do here? I get rid of the square by saying, well, that's sine of x plus the cosine of x, right? And I go ahead and multiply those out. When I do so, I get sine times sine is sine squared. Sine times cosine is sine cosine. Cosine times sine is sine cosine. Cosine times cosine is cosine squared. Now I have this little guy and I can combine my like terms, right? So I combine these two and that gives me this right here. Now this is interesting because we start to realize something, and that would be if I could rewrite this order. So if I move the cosine closer to the sine, say sine squared of x plus the cosine squared of x, we should recognize that because sine squared x plus cosine squared x is equal to 1. So I'm going to substitute that in for it. I'm going to put 1 in for sine squared x plus cosine squared x and get 1 plus 2 sine x cosine x. Now I went ahead and pulled down our 1 plus sine 2x. I'm not quite there, but I realize that this is getting really, really close to this. So what's our other identity? Well, we also know that 2 sine x cosine x is the same as sine of 2x. So if I plug that in, I end up with 1 plus sine 2x equals 1 plus sine 2x. So these are using our identities. We use these two identities to solve this out. Look at example 96.2, and they want us to show that the cosine to the fourth x minus the sine to the fourth x over the cosine 2x equals 1. Now I went ahead and said, well, what if these weren't sine and cosine but were a little easier for us? What if it was a to the fourth minus b to the fourth? Well, I would recognize that as a difference of two squares. And when I factor that, I would get a squared minus b squared and a squared plus b squared. So I go ahead and plug that in. I get cosine of squared x minus sine squared x, and cosine squared x plus sine squared x, still over cosine of 2x. Well, at this point, I realize that I have another identity, right? Remember this right here, cosine squared plus sine squared? Well, what is that? Sine squared plus cosine squared is equal to 1. So if I plug a 1 in here, I end up with this, because 1 times that is the same. Now I'm simplifying this down. Well, if only I had another identity. Well, if you remember, there's another difference identity with cosine and sine, and that is the cosine squared x minus the sine squared x equals a cosine of 2x. That's my double angle, right? We already have that as identity. So if I plug that in and say, well, there it is, therefore I can say cosine of 2x, and cosine of 2x divided by cosine of 2x is equal to 1, and so it does work. And these are just working with the things we already know to solve things and show what is already equal.